Okay, so the question says a 0.72-meter diameter solid sphere can be rotated about an axis by a torque of 10.8 newtons, which accelerates it uniformly from rest through a total of 160 revolutions in 15 seconds. And it asks for the mass of the sphere. Now, we can solve the mass through the net torque formula, which includes uh, rotational inertia and acceleration. And that equation is net torque is equal to rotational inertia times angular acceleration. If we expand that, that becomes net torque is equal to 2 over 5 times mass times radius squared times angular acceleration. This 2 over 5 times mass times radius squared is the rotational inertia of a solid sphere, of a uniform solid sphere. And the variable we're trying to solve for is m. However, we also need to solve for this variable, alpha, which is angular acceleration. And in order to do that, we need to use a formula. In this case, it's going to be the angular displacement formula in order to solve for angular acceleration. So let's first write out our givens. So we know that our diameter is 0.72 meters. So we'll write that. And then we know that the net torque applied is 10.8 meter newtons. And then we know that it rotates 160 revolutions. Now, revolutions is pretty much useless to us in this scenario, so I'm going to go ahead and convert it into radians. So in order to do that, the conversion is 160 revolutions is equal to times 2 pi radians over 1 revolution. Once revolution, the variables cancel out. We end up getting 1005.31 radians. So the angular displacement is 1005.31 radians, and our time is 15 seconds. Now we can go ahead and plug this all into the first equation to find angular acceleration, which in this case is going to be theta is equal to initial angular velocity times time plus 1/2 times angular acceleration times time squared. Now we can go ahead and plug in our variables, and we're solving for this, which is going to be angular acceleration. So we know theta, which is 1005.31 radians, is equal to 0 since the initial angular velocity is 0 since it accelerates uniformly from rest, plus 1/2 times angular acceleration times time squared. In this case, it's 15 squared. And our angular acceleration, once we plug it into the calculator, is going to be 8.94 radians per second squared. Now that's the first part of this problem. Now we can go ahead and, since we have angular acceleration, we can go ahead and use this net torque equation in order to find the mass of the sphere as a whole. So we know our net torque is 10.8 meter newtons. That's equal to 2 over 5 times mass, the variable we're solving for. Our radius is 0.36 meters. Since our diameter is 0.72 meters, we just divide that by 2. So 0.36 meters, square that, and then our angular acceleration in this case is 8.94 radians per second squared. Now, when we plug that all into the calculator and we solve for m, we end up getting 23.30 kilograms, which is our final answer in this situation.